Good afternoon. Uh, let's start the class for C++ and data structure. Lecture 4, CSB, course code CSB 1212 and CSB 1251. So these are 4 lectures on this subject. Uh, Today's class content will be on the block 3 introduction to data structure, unit 11 and unit 12. So objective of our class will be understanding the concept of linear data structure, explain the working principle of stack, which is L-4, last in, first out, and Q is P4, first in, first out. Implement stack and queues using arrays and linked lists. Perform basic operation like stack, push, pop, queue, and queue, dequeue. Identify and handle condition like overflow and underflow. Understand nonlinear data structure, tree concept, understand the concept of tree balancing. Now, moving to our slides in Unit 11, let's first understand what is stack and queue. Stack and queue, implementation and operation and application. So, introduction to stack and queue. Stack and queue are linear data structure used to store, manage data efficiently. Follow the specific order of insertion and deletion. Now, let us go deep in the stack concept, which follows L-4. Last in, first out. Last inserted element is removed first. Example, stack of plate. Stack of plate. First we insert in the bottom, add plates at top and remove plates at top. So last in, first out. So this is the example of stack. Stack operation are there are 4 operations: push, pop, pick, that is top or is empty. So push is add element to top, remove pop is remove element from top, and pick or top is view top element, or is empty is check if the stack is empty. Okay. Next, stack operation example. Example when push 10, pop, push 20, push 30, and stack will be first. Which one is push? 10, right? So 10 will come first, second 20, then 30. Then pop means removes 30. So which one is inserted last? That will be removed first in the stack. So implementation of stack using an array uses an array to store element. Okay, maintain a variable top. Example, array size 5. So now push 10, 20, then top equal to how much? 1, 0, 1. The index of the array starts from 0, then continue with 1, 2, 3 like that. Next, implementation using linked list. This element is a node, top point to the first node. Okay, linked list, like a linked list, it's done. So implementation of stack using linked list. Example here, 10, 20, 30. So top is what? Which one is last inserted? 30 is last inserted in the previous example. So 30 will be top. Now let's understand the queue concept, which follows P4. That is first in, first out. First inserted element is removed first. Here, first inserted element is removed first. The stack is L4. Last inserted element is removed first. Okay. Example: the queue at the ticket counter. So first in, first out. Queue operations. There are 3 queue operations: NQ, DQ, front or pick. Okay, NQ is add element at the rear, means from the behind. Okay, from the back, and remove element from the front. Peak, front or peak is view first element. Example, NQ 10, 20, 30 is there. So 10 comes in first, second 20, then third. Now DQ. DQ means removes. Removes, which one will be removed? The first in. So first in is 10. So first in 10 will be removed first. Q, continuing Q. Q implementation using array. Uses an array with front and rear pointer. So here what it's used? Rear pointer. Pointer will be used like front and rear pointer. Example, front equal to 0. That is our initial value index in the array. So rear is 2. Rear is the last. From behind only 2. So 0, 1, 2. Okay, 3 values will be there. So Q using linked list. What it does, nodes connected dynamically. Okay, front points to the first node, then rear points to the last node. Okay, front means first node, then rear means the last node. Application of stack and queue. Let's understand the application of stack and queue. First, stack. Stack, application of stack, expression evaluation. Example, 2 plus 3, then multiply 4. Okay. Here, undo, redo operation is there, function call is there, call stack, and checking balance parentheses. So there will be parentheses, there is symbol, there are addition, multiplication, and numeric value in the example. So example expression A parenthesis A plus B close parenthesis valid using stack. So this is valid for using stack. So application of queue. CPU scheduling will be the application of queue, printer queue, and bread first search, PFS, customer service system. So first in, first out, right? So this is what the application of queue will be look like. So advantage and limitation of stack and queue. Okay, advantages: efficient data handling, easy implementation. Limitation will be fixed size in array, and overflow, underflow will be there. Note: stack use L-4 as we have discussed earlier, and queues use FIFO. FIFO method, first in, first out. So you're moving to our next unit, unit 12. Okay, trees and binary search tree. Introduction to trees, nonlinear data structure consists of node and edges will be there, represent hierarchical data. Okay, example will be family tree. So basic terminology will be root, that is top node, parent child, leaf node is no children, and height of a tree. Okay, binary tree. Each node has at most 2 children. Okay, left child and the right child. So example here you can see this is the node. This is which called root, and left child and the right child. So here right child is greater than the left child. This is what binary tree will look like, and each node has at most 2 children. Remember that. And unit 12, classification of data structure. Classification of data structure. See here, binary search tree, that is BST, right? Binary search tree short form is BST. Special type of binary tree will be there. Left child, parent, and right child. So left child will be this side, then parent will be center, which is also called as root, and right child will be right side. So you see, parent left child is less than parent, and parent is less than the right child. Okay, this one you have to remember. This is the example. 10, this is left child, 5 is left child, 10 is parent, that is root, right child is 20. BST properties. First, start searching ordered structure will be there, no duplicate element usually. So tree traversal. Tree traversal, what is tree traversal? Traversal equal to visiting all nodes. All nodes. Type pre-order. There are three types: pre-order, in order, and post-order. So pre-order traversal, root will be first, then left child will be visited, then right child will be visited. Example 3. Pre-order 10. That is root. Root will come first, left, fifth. 5 is the left child, then right. Right is 20. Same example we have discussed here in order traversal as well. Let's to understand better the difference between pre-order, in order, and post-order. So in order, now left child will come first. Okay. Then root. Root is parent. As I have told earlier, root is parent, that is 10, and right will come in the output. Okay. Then post order traversal. Left, right, and root. Left, again, you see the difference. You see in post is right is root first, left, then right. Here in order, left first, root, and right. Give sorted order. This will be sorted order, like 5, 10, and 20. Now, sorted order. So, post order, traversal left, right, and root. Example 5, 20, left, right, and root will come post order. So, this is the difference between three traversal types: pre-order, in order, and post order. Next, BST operation. Breadth search. You see what is BST? Binary search tree. Okay, binary search tree operation, insertion. So let's see the insertion part. Insert element in the correct position. Example, insert 15. So 15 is less than 20. So it will come left child of the 20. Okay. BST operation searching. BST operation searching. Compare value with roots. Compare value with roots. Move left or right. It will move left or right. So example, search 15. So search 15, move left or right. Then right after right will move forward to find a child. So found in the right subtree. It will be the answer. BST operation continue. BST operation deletion. In case 1, node is a leaf. Then remove. Case 2, one child. One child will be replaced. Case 3, two children used in order successor. So when node is a leaf, then it will be removed. Okay. And one child, then it will be replaced. Two children, then used in order successor. Balancing in BST. Balanced tree, faster operation, unbalanced tree, then behaves like a linked list. Okay. Example, sorted insertion, unbalanced tree. Application of tree, file system, databases, search engine, expression tree. So you see example what is given in balancing BST is when it is sorted insertion, then it is an unbalanced tree. Advantage and limitation of tree: efficient searching, hierarchy representation. Limitation will be can become unbalanced, complex implementation. So these are the self-assessment questions for you to solve and study at home. What is stack? Whichever we have defined or understand in the slide, these are the self-assessment questions. Define LIFO. What is Q? Define FIFO. What is the post operation? What is the pop operation? What is NQ? What is DQ? What is stack overflow? And what is stack underflow? Okay. Go through your SLM and solve the problem as much as possible to understand more in detail. If you have any doubt while reading your SLM and understanding, you can always reach out in this email ID given here. Thank you. Thank you for the class. See you in the next class, 12:30.